Okay, let's continue for our discussion about the electromagnetics. So here is the section 1.5, 6, and 7. We will talk about electrical field and associated electrical force. And next is the magnetic field and magnetic force. The two force, electric and magnetic forces combined, is so-called the Lorentz force, which has great influence on our daily life, as we will see a couple of examples. So in section 1.5, we will discuss about electric fields, 电场, and well, before we proceed for the introduction of electrical field, let's review the so-called gravity field first. And as you know, Newton's experiment shows that the gravitational force of attraction exists for anything that have mass, that anything have the masses, and gravitational force is proportional to the product of the two objects of masses, and the force is inversely proportional to the square of the distance between the two objects. So after a couple of observations and derivation, the gravitational force equation is introduced as the form of m1, m2, g over r to the square, where g is the so-called universal constant of gravitation, which is 9.8 blah 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 with its unit or something like that, right? And in a similar fashion, a force field can be formed for two objects with electric charges, So the prerequisite for the electric force or electric force to take action is that they must have electric charge. And unlike gravitational force or gravitational field, which is that only has the force of attraction, the type of force of electrical force can be categorized as two types. One is the force of attraction, and the other is force of repelling. And like charge repel, unlike charge attract. 也就是说我们讲的同性相斥，异性相吸，这是电场作用力跟重力场作用力主要的区别。And here is the unit for electrical field. No, that's the unit for electric charge. So the direct source for electric field is electric charge. So that's probably one thing that I would like you to memorize. That is the direct source of E field is what? Is low electric charge. Well, which I suppose that you already know. So what is the direct source for magnetic field, which is also referred as H field, magnetic field? Well, the source for magnetic field is, and I suppose you know that already, is current, electric current. That's the direct source for magnetic field and the direct source for electrical field. Do they have interactions? Do we have interaction between electrical field and magnetic field? Well, it depends. For the study of static, electric, and magnetic field, 对于静场来讲，for static fields, in fact, the electrical field and magnetic field are not coupled. One example, if you have a magnet, or if you have a campus, campus, 什么是 campus? 指南针嘛，哈，家里有指南针。Well, we know that the campus will always pointing to the north or the south. Suppose you put the campus in a box made of metal, say a cookie box, a metallic cookie box. What happens with the campus? Was that still pointing to the north or pointing to the south? You know that if you put your cellular phone in a closed magnetic box, what happens? Well, the signal cuts off. You will no longer have the signal from the base station. Why? Because the shielding effect cuts off the electrical field as well as the electromagnetic wave. And for another example, you hear the Sunday this morning? Did you? And of course, the Sunday is a natural phenomenon. It takes place every day. If you ask an astronaut that when he or she is in the orbit in the space station, well, one thing that they see in their everyday life is there are sounders everywhere in the Earth's atmosphere, right? So for an airplane, it's very likely that it will be hit by sounders every now and then. But is that a problem of safety? Well, it may be a security issue if it's hit by large sounders quite frequently. But if the frequency is not that high, then in general, the airplane is okay even flying in a thunderstorm. Why? Because the airplane is made, the enclosure of the airplane is metallic, so the shielding effect of good conductor will stop the electrical field from entering the interior of the airplane. So what happens with the campus? Well, with the campus, was that still pointing to north, or will it rotate like a crazy? Well, the answer is the campus in the metallic box still points to the south or north. Why? Because for static field, such as the Earth's magnetic field, it's decoupled with electrical field. So the shielding effect of metal box only affects electrical field, and it does not impose any influence on magnetic field. So they are decoupled. Okay? So that's probably one thing before I proceed for the rest of the discussion about electrical field. For static field, electric and magnetic fields are decoupled. They are not related to each other. Nevertheless, for time variant field, in particular for electromagnetic wave, the electrical field and the magnetic field are coupled. They cannot be separate. So that's the reason why if you put a cellular phone in the metal box, it will cut off the transmission from your phone to the base station. Why? Because the metallic box cuts off the electrical field. And because the magnetic field is coupled with the electrical field, so the magnetic field is cut off as well. So a metallic box can shield the propagation of electromagnetic wave. All right, so go back to the slide. Another thing we learned from this slide is that the amount of electrical charge from an electron is minus 1.6 times 10 to the minus 19. Okay, one problem with electrical circuit, or one problem with electromagnetics is the definition of electron. Now, we define electron as a negative charge, which turns out to be a poor choice. It's end up with some issues when we write up equations pertinent to the electromagnetic field. So some have urged that we should change the polarity of electron into a positive one. But after reviewing this idea, it seems that, oh, come on, we will all rewrite the textbook all over again. So let's forget about it. Just live with that. Okay, so electron is still defined as negative charge, while protons are defined as positive one. But for electromagnetics, the polarity does not really matters. All right, it's just a sign. Negative or positive one doesn't matter that much. Well, but that's not the case when it comes to your exams. Right? You still need to write the correct answer with the correct polarity. All right, and so this slide summarizes a few findings concluded by Coulomb. So it's referred as Coulomb's law because he made a bunch of experiments, and he brought up some observations and end up with this relationship that governing the electric force due to the presence of electrical charge. So the first one is the magnitude of electrical force is proportional to the product of the magnitude of the charge. All right, so Q1 and Q2 refers to the amount of charge of 2-point source. All right, so you need to notice that this equation, the Coulomb's law equation, applies to the so-called point sources. Okay, so this equation is valid only when the two charged particles are small in volume. Small in volume， 体积很小的，带电荷的那个体积是很小的，小到可以忽略它的体积大小。这样子的话，所谓的点电荷的假设才成立哈。你的库仑的这个电场作用力的式子才是现在这个形式。假如它的体积很大的话，那状况就不太一样了哈。Alright, so the prerequisite for the Coulomb's law for the electrical force is that for 2-point charges with 2-point charges, the force is proportional to the product, and the magnitude is inversely proportional to the square of distance between the two charges. So here is the R2. You can see here. The third thing is the magnitude of the force depends on the medium. It's related to the property of the surrounding material. If the surrounding material is air or vacuum, then it can be described as 4 pi epsilon sub 0. So the 4 pi epsilon sub 0 is pretty much like the G constant in the gravitational force, in gravitational force. For electrical force, the material dependence is described by 4 pi epsilon sub 0. Well, 4 pi epsilon, well, the material dependence is actually the epsilon sub 0, which is referred as permittivity in electromagnetics. 在电磁学里头，我们把 epsilon 0叫做真空的介电，其实叫介电系数吗？其实不太一样的，介电系数其实应该叫做 dielectric constant。但有时候另外一个名字叫 permittivity permittivity。这两个在中文上面好像都翻作介电系数OK， 好吧，有点困扰。OK。好吧，so epsilon sub 0 is referred to as the dielectric constant or permittivity of vacuum. What is the value? 8.895 times 10 to the minus 12. Well, if you teach electromagnetics for 20 years, of course you can memorize this kind of constants. Well, another interesting about this thing is actually I'm not that buying the idea of permittivity. Because this is the permittivity, this is the dielectric constant of vacuum, which means nothing. So in an empty space with nothing, it has the property, electrical property of permittivity, pretty much like the rest of our material where the stone, the wood, the plastics all have permittivity. However, this is not a, well, this term has a long history. As you know, the electromagnetics is established around the area of Maxwell. Okay, so you have Maxwell equations. And one interesting thing is at the 19th century, that is, around the time of Maxwell proposed the idea of Maxwell equation, most of the scientists believe that believe that the world is made of ether, or in other words, that there is something called ether fill the entire universe. 以太论 The word Ethernet, as you know from the connected internet, is coming from this idea that ether, which is a medium that filled everything, filled everywhere in the space. So for Maxwell, he believed that electric field and magnetic field is pretty much like water. Water is a medium, or it's like a fluid that can flow in the space like water. Electric and magnetic field can flow like water in the space. So the relationship between electrical field, magnetic field, electric flux, magnetic flux, which we will come up later on. So all the equations related to electromagnetics are interpreted in terms of flux, in terms of fluids. 所以电磁学的概念，它其实是从类似流体力学的方式去推导出来的，而事实上，这些关系式跟流体力学的样态也非常的接近，也就是他们的求解啊什么的。其实电磁学的求解，其实从流体力学或热力学那边吸收了很多的养分跟启发了，所以整个电磁学的诞生，其实是在一个错误的假设底下，也就是说， 他认为整个宇宙是由以太所充斥的哈。那既然宇宙中到处充满以太，那个 epsilon 0就不足为奇了哈。那个就是以太本身的 permittivity 哈。So interestingly, the idea of Maxwell equation is established from a wrong assumption. That is, the universe is filled with ether. And of course, we know that there is no ether in the universe. So the basics for Maxwell equation is actually no longer exist. Nevertheless, the equations, the relationship that governing the interaction between electric and magnetic force, the association of electric and magnetic sources with the fields are still correct, are still valid. Okay, so why bother? We just adapt or just use these equations to do our study, to perform our engineering. It's still okay. So the sky is not falling. All right. So let's continue. But it's an interesting idea that Maxwell equation was all begin with our wrong assumption about the nature of electrical and magnetic field. All right. So we know that the electrical force is associated with material property. For electrical force, the property is permittivity. How about 4 pi? Does that ring any bells? 4 pi. Well, 4 pi is associated with geometry. So, as you know, for a point charge, the electrical field is established by this point charge. Say it's a positive Q, positive charge. The electrical field established by this point charge is pointing outward uniformly, pointing outward isotropically. So the space, the spherical space enclosed by this spherical area is the size of this the radian is actually 4 pi. Okay, so that's why we have 4 pi here. This is actually related to the nature that for a point charge, the distribution of its electrical field is spherical, and the distribution is kind of homogeneous. All right. The fourth thing is direction of force is along the line joining the charge. That's I suppose you already know that the electrical force is aligned with the direction of the vector between that links the two charges. And the fifth thing that I already mentioned, like charge repel, unlike charge attract. 同性相斥，异性相吸. Oops, all right. Okay, and so as I already mentioned, epsilon sub-zero is known as permittivity. All right, so practice with your tongue. Permittivity. That is the constant pertinent to the relationship between electrical field intensity and the electrical flux density, which we will describe a little bit later. D, okay, this is the electrical flux density, 电通量密度哈。Electrical field intensity, 电场强度 and also the permittivity regulate the relationship between electrical flux density and electrical field intensity. Another thing is B, magnetic flux density equals to mu times H. Magnetic field intensity 磁场强度 magnetic flux density 磁通量密度 mu permeability which is referred as 介词系数 in Mandarin 介链系数、介词系数。Actually, the third relationship about electromagnetic property of material is relatively simple. There are only 3 relationships. So here are 2, permittivity and permeability. How about the third one? The third one is simple as well, which you already know. That is this. What is this? What is this? Conductivity. 导电系数啊，你怎么会不知道嘞 ？Conductivity. So conductivity specify the relationship of external electrical field with what? Current density. 电流密度嘛，电流密度等于导电系数乘上电场强度。So conductivity, permittivity, and permeability are actually the 3 fundamental relationships between material and the electrical field, electromagnetic field. So these 3 equations are referred to as constitutive relationship. The constitutive relationship. 有没有看过这个字？ Constitutive， 我们同事有没有宪法？我们现在的同事没有课文有宪法，OK 好。我念书的时候那个什么宪法课都修一修，然后可以好好睡一觉这样子。好啦，所以宪法叫什么 ？Constitution 嘛，对不对？Constitution 宪法 ，constitutive relationship. So, which means that they are the fundamental relationship between materials' electromagnetic property with the electrical field. All right. So come back to here. Here are the another important relationship. Okay. So as I already mentioned, epsilon sub 0 is known as the permittivity of what? Of vacuum. Of vacuum. Which is 8.854 times 10 to the minus 12, which is, interestingly, can be expressed as 10 to the minus 9 divided by 36 pi. All right. And actually, I don't know why it can be formed with such interesting numerical expression, right? However, the other thing is important is here. To the left says that F1 equals to Q1 times Q2 divided by 4 pi epsilon sub 0 R2 A21. What is the implication of this equation? It describes that this is a force exerted by Q2 onto Q1. 有同学反映叫我用中文但这其实是违反 EMI 课程的那个核心定义的但没关系嘛我都已经正教授了，对不对想找麻烦的话来找我麻烦没关系OK 我不要不得惊OK 但我觉得但是多少还是尊重一下所以我尽量不要穿插太多的中文了但是比较核心的部分，我担心大家可能还是听不懂我比较蹩脚的英文的时候我还是会稍微用中文补充一下但原则上我们还是尽量符合 EMI 的精神了好不好但你不可能预期说我都用中文讲了毕竟这一门课还是写 EMI 了那同学说可德老师有没有中文讲课？有在 Moodle 上自己找一下，我有放去年的那个中文讲课的那个的 YouTube 的影音连结所以有的自己稍微找一下在 Moodle 上面 All right. Okay. So F1. So well, actually, we have two equations, F1 and F2. What are the differences between the two? F1 is the electrical force exerted by Q1 onto Q2 onto Q1. So the unit vector here, A21, which is pointing from where to where? It's pointing from point 2 to point 1. Oh, that's the beginning, that's the end. From point 2 to point 1 suggests that this force is pointing from Q2 to Q1. This is a force resulting from the presence of electrical charge Q2 exerted on electric charge Q1. On the other hand, there will be another force exerted from Q1 onto Q2. So F2 has the direction of A12, which means it's from point 1 to point 2. And as the equation suggests, you see the two forces are of the same magnitude. However, their direction are opposite. A21 happens to be the opposite direction of A12. So this is the force experienced by Q2, while this is the force experienced by Q1. So the Newton's law of force, the third Newton's law of force still holds. The amount of force and 作用力跟反作用要怎么讲？我不会讲 ，OK 哈。你知道吗？哈，牛顿第三定律嘛，哈，大小相同，方向相反，好。Alright, so the third law, Newton's law of force still holds for the electrical force. Okay, so this relationship is referred to as Coulomb's law. Here is the graphical representation of F1 and F2. So F1 is resulting from the presence of Q2 on Q1. F2 is resulting from the presence of Q1, and the force is exerting on Q2. All right. So F1 and F2 are of the same magnitude and of the opposite directions. And the force, well, one interesting thing about this is if there is a charge Q2 takes place here, and if you have another charge Q1 placed over here, of course, Q1 will experience the force F1 from Q2. How about if I remove Q1? What happens? Well, you observe nothing. Nothing happens. You observe nothing. However, the field established by Q2 are still there, no matter you have Q1 or not. So the idea of electric field is proposed to describe this kind of a situation. The presence of a charged particle shall establish a field so that if you put another charged particle in the neighborhood of in this area, you will experience a repel or attract force depending on the polarity of the charge. Okay, and this field is there no matter you have a charged particle or not. 所以这里我喜欢的解释是就是你有一个带电荷摆在空间当中，它就建立起有一个水在那啦，但是你必须要拿另外一个带电物体才会去感应到那个水。那它的表现就是电场作用力，但 只要环境中有那一个带电物质，它的电场被建立了之后，那不管你附近有没有另外的带电物体，都会有那个被建立的电场。所以用电场这个概念来去描述这样的情况、这样的情境，会比较通用嘛。就是说你不仅仅看到电场作用力的出现，才能够了解有带电物体在那边。即便没有其他的带电物体，你一样可以来去形容、描述这一个带电荷在空间中所建立起来的影响。So the influence of a charged particle can be described in terms of electrical field intensity, no matter you have another charged particle or not. So the electrical field intensity is defined as F over Q. F is the force if you put another charged particle to the vicinity, to the neighborhood of the charged particle. And the charge of your charged particle is Q. Okay, so Q is the charge of the new one, of the other one. And F is the force if you place a charged particle Q in the neighborhood of the original charge. So E is determined as F over Q. So electrical force is a vector or a scalar? A vector. Charge is a scalar or a vector? A scalar. Oh, sorry. F is a vector. Q is a scalar, and E is a vector. Great. And the unit for electrical field intensity is voltage over meter. Voltage over meter. Which suggests another relationship, that is V voltage equals to E times D, right? The distance, the voltage, or which is referred as electrical potential in electromagnetics. The official name for electromagnetics above E is electrical potential, 电位能，电位能 is D dot E. What is V? Is that a vector or a scalar? No, okay. Because electrical field is a vector. D, the distance, actually has the length and direction. Okay, so it's a scalar product. So V is a scalar, all right? Now, and so you can see the unit of E is coming from that relationship, voltage over meter. So if you dot product it with the direction of movement, you will end up with the amount of potential difference observed on this path. So it's volt per meter. So the test charge should be, so here are some other relationship about the electrical field or electrical force. One example is that the electrical field intensity is defined in the limit that Q tends to 0. So it's some of the assumption we made about electrical field. That is, the Q should be a very small number. Okay, the amount of charge should be very small for this relationship to be valid. Okay, so a charged body is the source of an electrical field. I already said that at the beginning of the class, that the other thing is the electrical field only exerted electrical force on charged particle. And using this relationship, we can do some application. One example is stated down below. This is the so-called electrostatic separation, that you can use electrical force to separate minerals. Minerals. 用静电力来分离矿砂了，Okay, and here is another example. Do you know what it is? 小朋友有没有看过这个东西？实体啊，有看过吗？我20年前刚开始教电磁学的时候，大家都看过哈，都知道哈。现在我对于这件事已经没有把握了，可能大家真的要到博物馆去看这玩意儿了吗 ？OK 但是我从小看这个到大的哈 ，OK 哈。So this thing is referred to as the cathode ray tube. Cathode ray tube, 阴极射线管哈。So this is one well before the invention of a light emitting diode, before the invention of LED, all the display we have are made of cathode ray tubes. Which is a very genius invention, from my opinion. That is, well, the cathode ray tube, which is labeled as 阴极射线管 here, is also referred to as 荧光幕 in Mandarin, because the mechanism for cathode ray tube to display is by emitting high-speed electrons onto a screen made of fluorescent particles. 荧光物质，电子打上去让它发光。So about 40 years ago, when I was a grade 6 elementary school student, I was really excited to have my first computer lesson, right? About really 40 years ago. And it takes us, so we are brought into a classroom with computers, right? Of course, a computer with a screen. And once you turn on the computers, it probably will take 5 minutes for your computer to load up the BIOS through cassette. 你们听过录音带？所以那个 BIOS 的那个那个时候还没有 static RAM， 那时候电脑还没有 static RAM， 所以它的那个作业系统 BIOS 是要读磁带的，读那个卡夹的哈 ，OK。And of course the display is mono 单色的那个阴极射线管就是黄色的，我不知道你们有没有看过哈 ，OK， 可能古早的电影上面有看过吧哈。Well, how does that operate? Well, actually, this is the cathode 阴极 ，this is the anode 阳极哈。So, well, there is an electrical potential applied between the two. So, here in the cathode, you will heat it up. It's made of, the cathode is made of with a specific metal alloy. That is, when this metal alloy is heated, there will be some free electron generated from the surface of this alloy. Then these free electrons will be speed up by the potential difference between the anode and cathode. So this free electron will shooting up to this direction, and once it passes through this region, the voltage potential applied on vertical plates or horizontal plates will deflect the electrons to a certain angle, so that the electron will hit to a specific spot on the screen, which is covered with fluorescent particles. So it will glow. Well, usually it's yellow, glows in yellow color. So the spec for cathode ray tube is the scanning rate, which is usually about, well, the minimum is 30 hertz, which means that it will scan hold the position on the screen 30 times a second, so that it will exhibit an image, a full image that you can observe, that you can differentiate, right? So it's kind of a neat invention, neat. It's really neat. I see the mechanism, the inventor for this device is really genius. All right, okay. And of course, there are no longer but in some old school electronics, such as Russian era aircraft, you can still see cathode ray tubes, right? Alright, so here are some description about how cathode ray tubes works. So it's simply using this equation, the electrical force relationship, to deflect the path of the charged particles. Alright, so I will leave up the other text for your own, for you. Okay, so here are some closing remarks about today's lecture. So if you compare the Coulomb's law and the electrical force equation, you can identify that the electrical field intensity of a point charge. Note that this relationship only valid for electrical field distribution of a point charge. 这个式子只对点电荷所建立的电场有效。假如不是点电荷，就不是这个式子。我们礼拜四的时候会去介绍不同的电荷分布所造成的电场分布，但这个是最基础，从库伦定律可以直接给你点电荷的电场分布。So from this equation you see the electrical field is pointing outward if you have a positive charge, and the magnitude is inversely proportional to the square of the distance and is related to the material property, which is specified as epsilon. Alright, so for a positive charge, the electrical field will pointing away from the place of the positive charge. Alright, so okay, we will continue